We are live. You are watching day 2 of the J Champions Conference, the virtual conference that is organized and delivered by Java Champions offering free content for all Java enthusiasts around the globe. My name is Hanno Embrechts. I have the honor to moderate this session today, and I'm here with my fellow Java champion, Oliver Drootboom, also goes by Ollie. He said to me, only my mother calls me Oliver, when she's mad at me. Let's be all friendly here and call him Ollie. So Ollie is with the Spring team at VMware. He concerns himself with frameworks and architecture. He likes open source and, of course, all things Spring and all things Java. While Ollie is doing his talk, if you have any questions, feel free to drop them in the chat here. I will moderate them, and whenever there's a good moment, I will relay them to Ollie, and he will answer them in between. So today, Ollie will talk to us about Modulithic Spring applications and how to design the interaction of its modules. I'm very curious to see what he has to offer. With that being said, let's turn things over to Ollie. Ollie, ready when you are.
Thank you very much, Hanno, for that awesome introduction. As everyone can see, I'm kind of also the winner of the tongue twister email addresses competition. Because like hardly anyone can actually spend that or spell that, pronounce it. It's great to be able to have the privilege of opening the second day here. And I would like to talk about you, like as Hanno said, about these designing module interactions in Modulithic Spring applications, whereas actually there will be some Spring focus in the talk. It's also more of conceptual nature and probably hopefully picks your brain a bit about like the way you structure applications and the interaction between different parts of the applications, whether Spring or not, that might not even matter. I've been working in the Spring engineering team for like 15 years now, almost. I've primarily led the data projects for quite a while, and then have moved on into a more like, let's say, cross-project role, where a couple of folks in the Spring team and I are looking at customer applications and the architectural ideas they want to implement, and then try to make sure that the projects that we work on as a team do not interfere with these architectural ideas in the first place, and in the best case, they support them to a better degree, right? So the probably mostly known instance of that idea is the Spring Cloud projects. So when you're building distributed systems, you basically end up with a couple of like new challenges that you might not face with a non-distributed system, and Spring Cloud attempts to provide you tools to tackle these challenges. The project that I'm currently working on, Spring Modulith, is trying to do the similar conceptually similar things in monolithic applications. So it's like assuming you try to like create these individual parts of your application, it would basically try to help you with the challenges that you face with those, test individual parts of your systems, what have you. And the context of, or the original of this talk is as so many other of my talks, it's usually a tiny part of another presentation. So the general Spring Modulith introduction that I gave always talked about like, okay, now we established these parts. It's not something that we're going to discuss too much today, but you can find recordings of those on YouTube and the internet. But that a tiny part was always discussing like, okay, now that we've established the parts, how do we organize the interaction, and what does that mean for our application, for transactions and what have you? And that basically, this talk here is going into depth in that part. It's also basically the talk version of one chapter of the upcoming book, Modulithic Applications with Spring. I'm still arguing it's going to be done this year, but let's see how that goes. Right? So one person that has inspired a lot of my work in the last couple of years is Russell Ackoff. He's a systems theorist, and the first thing I discovered from him is a YouTube video, systems thinking, learning, and problem solving, in which he describes the fundamentals of thinking in systems and the consequences that lead, and often and misunderstandings that people often have. And it's like quite a philosophical talk. He gives very like decent analogies about like cars and your human bodies and whatnot as systems. But the things that are like interesting to me, or that made that talk relatable for me, was it kind of goes into the fundamentals of what a system is, and that's kind of transferable to software systems as well, right? So he starts by saying that, okay, the system, we have this whole thing and we have parts, and the interesting bit about these parts is that they affect, of course, the overall system's behavior, their properties, like how scalable is it, what have you. And the interesting bit here, or the most interesting bit here, is that it wouldn't be a system if one of the parts was not depending on some of the other parts for some functionality, which is kind of an interesting observation, because we often talk about coupling and attempting to decouple parts of our system, but there's no such thing as full decoupling, because as soon as the parts are fully decoupled, they're not the system anymore, right? So the question is, like, what kind of coupling do we actually introduce, and what are the trade-offs that we might have to deal with, right? So coming back to his starting point, it said the system is a whole, right? So this is a whole as well, right? So it's like one thing. And the question is, like, when it comes to parts, like, why do we even want to cut one single piece into multiple things, or in two, right? Like, you could have like one source code file, put all the code in there, and then basically run that. You'd be good. It'd probably be just functional, or could be made functional in some way. I mean, Perl programmers like have made a living out of that, right? Just one line of Perl even could like solve the entire business problem. But the primary effect of separating one thing into two is that we kind of have to put these things in relation again. So we kind of have to make one thing call the other thing, or depend on the other thing type-wise, or what have you. And why do we even do that in the first place? The reason we do that is, I mean, there's a couple of like very practical reasons for that, right? You could, let's say, we can have like different teams working on these individual parts of the code base. But fundamentally, it's that with separating one thing from the other, we can actually scope or contain the risk of a change to the thing that depends on the other, right? I can throw away A and not affect B at all. I can also change A, and by definition will not affect B at all. So, right, the risk of a change in A is significantly, or reduces the risk or the impact of that change to the overall system. And that's that idea of, okay, what is the scope of my change, and what does the structure look like? We will come back to that later on, because it's such an important factor in terms of, like, how do I even structure my system, right? Ackoff goes on in that talk and says, okay, and you've probably heard a flavor of this quote like 1,000 times already. The system is never the sum of its parts, but it's the product of their interactions. So there's two things in here. One is the kind of escalation from sum to product, which is probably to make the importance of the distinction clear. But separating a system into different parts is just one part of the exercise, because we have to re-establish the connections between the parts, and then let them interact with each other. And that, coming back to turning this into, like, okay, Java and Spring in this case, like, how do we actually establish code interaction? How does one piece of code, one class, interact with another class in a Spring application, or any kind of Java application? And that's by actually giving like one class a reference to an object of the other, which we now these days call like dependency injection, right? So traditionally, when I started with Spring, like almost 20 years ago, pretty much, you've already you had this notion of, like, there's certain stereotypes of classes in your application, like a controller calls a service, and the service calls a repository that abstracts the database access, and what have you. So this is essentially a layered architecture, right? So you have some kind of like stereotypical assignment. So a controller class belongs to the presentation layer, service belongs to the business layer, and what have you. And there's like a dependency direction, right? The service would get an instance, or the controller would get an instance of the service injected via dependency injection. Before that, he would maybe using lookup factories or static factories or what have you. And that's kind of like, while it's not explicitly described that way, but it's essentially a layered, following the layered architecture principle with a bit of domain-driven design language like sprinkled on top of it, like repositories, right, for example. But then, like in the following years, in the early, I think 2010s, things like the onion hexagonal architecture were not invented, but originally described, that somehow kind of do the same, but different, right? So you can argue that layered architecture is a bit specific on saying, okay, we have a presentation layer. For a hexagonal architecture, it's like even more generalized into a driving adapter. So things that could trigger the system, right? So it could stimulate the system. Whereas the like persistence side seems to be very specific, is generalized into like driven adapters, like stuff that the system interacts with as a response of some application functionality. And the outer adapters only interact with the application through ports that the application basically provides, right? Same for Onion. It's like the infrastructure ring, and then you have the application and domain ring. The reason I mentioned that explicitly is twofold. Like, for one, like I've seen, or it might just be my bubble, but I've seen a lot of discussion about like how to implement hexagonal architecture, yada yada, or Onion architecture, and then there's like, oh, you need to create packages for these different stereotypes and whatnot, and it's all kind of like a very technical decomposition of your system, right? You care a lot about like, is this thing an adapter or not? And on the other hand, is like, I was always feeling like, okay, if I've been implementing Spring applications the way I did in early 2005, 6, what have you, I kind of have done hexagonal architecture already. I just didn't call this thing driving adapter, but it was a controller. And it's not been like an application piece of code, but it was just the service, or the repository was a driven adapter. The same for Onion architecture. So the additional level of separation you get, and the goal of those architectures being testability in most cases, that's kind of like what you got it's never been officially described, but the way you developed Spring, or even like it's a Jakarta E applications all the time, right? Because like, there's been some natural way to decompose the technical infrastructure from the application domain. So, and the second point being, so one being, okay, it's very, very technical focused and not too new, to be honest. The other thing is that in a natural, like since Spring, and also then following later on in standard Jakarta applications, dependency injection. So the notion of like providing an instance of the repository, injecting that into the service, and injecting that in turn into controller, has been the primary way to connect like managed bean instances to another bean instance, right? So that's kind of been a very established pattern, and that's been what Spring developers have been for 15 to 20 years, or have been used to. So the problem I see with these like newer, with the current discussion around these hexagonal Onion architecture, is that the technical decomposition doesn't really solve the problem we primarily have in application development. The primary problem I see, at least in the customer applications, is not that they might have, oh my gosh, they might have used JDBC template in an application service, but that their functional decomposition is either virtually non-existent, or it's a tangled mess, and like literally everything calls everything, like functionally wise, business wise. So the thing I'd like to put kind of in the center of this talk here is that the way you structure your software system is essentially a formalized bet on the change patterns you anticipate having to deal with in the future. I almost never read out slides, but this is like so important, and I don't think there's anything I can really take away from that sentence here, right? So we need to decompose our system in a way, structurally and also from its runtime behavior, that we will be able to, let's say a new feature request comes in, that we're likely to be able to implement that feature request by touching as few elements of our structure as possible. Why is that? if you remember that A-B thing, right? The fewer elements we have to touch, the less risky that change is to our system, right? That's kind of the idea. If we only need to change one part, then all the parts that we depend on, by definition, cannot break by changing that A thing, for example, that we have. So let's have a look at what a business decomposition theme could actually look like in an e-commerce application. So when we check out, let's say we have something like Amazon and whatnot, we submit an order and there's some checkout process going on, and the customer decides, okay, this is the 4 pans I want to order, and I submit this order, right? So then for one, there is usually some kind of primary functionality triggered, primary state transition. The cart is basically transferred or the order is kind of materialized from a cart with all the line items that are in there. So that's kind of the primary step that we perform in a single state transition. I don't know. That said, that such business state transitions usually trigger functionality in other parts of the system. For example, when I trigger the checkout, I would have to update the inventory. So the 5 pans that some customer just has ordered have to be removed from the stock or from the inventory, right? We have a rewards program with our customers, so we need to calculate, depending on the value of the order, we need to calculate some bonus points that would then basically shape future rebate programs or what have you. And also we would like to send out an email to the customer, basically telling her the order was placed, you're about to be shipped in a few days or what have you, right? So that's kind of the functional state of affairs. It's not even not technical. It's just like we're describing what functionality is attached to our primary and secondary functionality. Oftentimes, neither developers nor business experts perform making that distinction. They just say, oh, in the order process, all these things need to happen, and it's kind of considered a one thing. That usually leads to the fact that we also implement it that way. So let's say we establish these logical parts in our applications, or in our application, right? The inventory rewards program in a typical Spring application, we would go ahead and integrate that system or these parts via DI. And the way that we do that is that each of these logical modules don't have to be like Spring Modulith modules or what have you, just logical units. There would be a class that has an add component or add service annotation on them, and that basically the logical modules expose that type. Spring Framework would create an instance of that at runtime, and then the checkout component, again also a Spring Bean itself, would kind of then reach out to the inventory and basically say inventory update, inventory rewards program, calculate bonus points, notifications, send out email, that kind of stuff, right? Let's have a look at the general structure of that in code, right? So there is our primary functionality in our checkout component would already use some kind of, let's say in this case, technical decomposition. So because the order repository is something that's internal to the checkout thing, so it doesn't have to be known to anyone else. And then we have a method that usually triggers a transaction, and it will trigger the state transition, the order.complete here, and then call order save on the repository, and we'll be good. That's kind of the primary functionality, right? Then that's kind of what I said. The next thing is the existence of, as I said, the beans of the different, as that form kind of the APIs of the other parts of the system. They have some API, like probably inventory has a method, rewards program, notifications one, a couple of methods. And the reason or the way that we would connect these things to the checkout is by using, in this case, like constructor injection. We require instances of these types to be present when we check out or when we instantiate the checkout type. And in our transaction, we then invoke those methods. Right, so that's kind of the state of affairs, and that's like interesting to, like, from a structural point of view, it means that these other things need to exist, right? The inventory has to be present. We have to have a bean around of the inventory. Either it's like the actual mock instance or the actual production instance, or it needs to be a mock. And that particularly becomes an important detail when we talk about tests, and we're going to do that in a second. That's a structural thing, right? How easy it is to actually create an instance for checkout. The more dependencies we have, the harder it is to instantiate the thing. Also, even if we do it with mocks, we kind of have to like find out about like how do we actually properly mock these methods, right? Or especially if they return results that we have to operate on, then that becomes more complicated. What's also at play here, and that's even more subtle, is the way that transactional works. Add transactional is a very convenient and easy way for us to say we want all that functionality to be like properly applied, atomically applied, or none of it, right? And this innocently looking at transactional on the complete method is kind of like tiny and like easy to understand if it only were easy to understand if it only included the call to orders.save. But now all of a sudden, like even if we have like structurally created order here, like the inventory thing is a separate thing, the rewards program is a separate thing, we've nicely decomposed our business functionality, but on execution time, we actually created transactional scope that surrounds the entire arrangement. Right? So for this bean arrangement, because we were using bean instances, the scope of consistency is still the entire thing, which means on the surface we have like structural clarity, but they are still tightly quote unquote coupled in a way that, for example, I don't know, an exception being thrown from the rewards program will still roll back the entire arrangement. And that's a blessing and a curse at the same time, because there's nothing fundamentally wrong with that, right? It's just that the more kind of functionality we attach to the checkout process, the more likely it is that some of these like secondary functionalities is going to like fail for some whatever reason, the bug or what have you, and that immediately renders the checkout process broken. So we often only think about availability of a system in a way that it's like physically reachable, right? We can actually do a call and it responds. But we can also significantly diminish the availability of a system by putting in some secondary functionality into that picture that's likely to break, because it would then render our checkout process like unavailable, right? If there's a bug in there. So the question is it really a good idea? It's definitely reasonable and it's convenient and it's easy to start with. It's just that the more complex your application becomes, the more secondary functionality you need to integrate, the more problems it can actually bring, right? So let's have a look at how we test that thing, because I've already touched upon this in the DI approach. The way that we write integration tests for the entire arrangement is that we usually write one of the at Spring Boot tests for that, an integration test. We auto-wire the checkout thing into the component that we want to test. And then we can either go ahead and bootstrap the other like inventory rewards program secondary functionality with the test, or we can replace them by declaring mock bean instances. That's a Spring Boot feature that would just replace a bean definition within the application context, right? And then the way that we, so that's kind of we mock the collaborators, and then we have this given when then approach, right? So we set up some state, we initiate the functionality that we want to test, and then we verify the outcomes that we expect. And with such an orchestrating approach, the testing is focused on exactly that, right? So we expect checkout complete to update the stock, right? Because it's kind of nice and easy. We know about the process, we know which steps we have to take, and that's fine. You could argue the other way around. You could argue, why would the team that works on the checkout process even have to know what other secondary functionality gets or has to be invoked? Right? We just want to make sure that we've changed the state of the order properly, and then whatever's doing, whoever is attaching onto that doesn't really, we don't really care about that. Assume we add another secondary functionality to that process. It would always require the checkout team to actively both integrate that into the production code and then also adapt their test cases, because we need to set up new mocks. Assumed behavior, which means that the checkout team has to kind of have built some level of knowledge around that secondary behavior, which is all like, it's okay, and it's especially okay if all of this stuff is managed by the same team, but at the same time, it's also increasing the complexity a lot, right? Right. So from the scope, like this is basically the thing that we started with. An alternative to like actively invoking the Spring Beans is that we could decide to like not do that, but instead let the checkout team just perform their primary state transition and then signal the outcome of that via an event, a Spring application event, and have the other components react to that event being published. An event in this case is nothing but a Java object, basically a value object even. And we would have to declare event listeners for that event on the secondary functionality side, which would look that, or to make the code look something like this, right? So the first thing, I mean, this is still our primary functionality. The first thing that we note here is that the dependencies to the secondary functionalities are gone, right? So we don't, the checkout team doesn't even have to know, that's what I mentioned before, doesn't even have to know like who's going to attach to that state transition. So we still have our internal dependencies. We have one framework dependency here, the application event publisher. That's a Spring type that allows us to, as you see down here, to publish an event. And the inventory and all the other secondary components would basically wait for or declare that event listener annotation. That's a Spring annotation in turn to on order completed event, and that would basically trigger the secondary functionality, right? So this would implicitly invoke that. The important bit to understand here is that this is nothing but a structural rearrangement. Behind application event publisher, there's a Spring component that knows about all of the event listeners, and when we call events.publish event, that kind of functionality, so this kind of, we invoke that method, it looks up all the event listeners and invokes them one by one. Synchronously, there's no asynchronous thing going here. It's basically just an observer pattern implemented, which also means that we are, the inventory is still able to break the transaction if it throws an exception, for example, right? So it's nothing but a different way of invoking the other parts. Yeah, exactly. That's kind of the idea. The way we would test that approach is something different, and I think it's important. There's this Spring Modulith logo in the lower right. You will see that always when there is some Spring Modulith support in the very slide, so something Spring Modulith specific. In this case, it's both the add application module test and the assertable application events type. That said, there is a flavor of the thing that I'm going to explain to you in a second in Spring Framework proper. So there, you don't necessarily need to use Spring Modulith for that kind of the fundamental approach. Because what we're doing here is we still resort to the given when then approach, right? Set up some state, invoke the method. But the assertions that we conclude the test with are different. We're not asserting on this thing has been invoked and that thing has been invoked, but we only wait for or expect that business functionality that we invoked to have published an event, right? And that's basically built or realized by that assertable application events type. That's a JUnit extension in this case that gets set up before we actually execute the method. It's registered as an application listener in the Spring Framework application context, and it captures all the events that are published while the test method is executed. So the checkout complete as you've seen on the slide before, publishes the event that gets automatically like just registered or kept around by assertable application events. And then we can basically say, oh, we expect that complete method to contain an order completed event that's been, it's referencing the order that we've just created, right? So fundamentally, I kind of like to describe this as the side effect of the business method invocation of the checkout complete method ends within the module boundaries, right? So we're not interested in like, is inventory invoked, is whatever else is invoked. We only care about the state transition in the checkout module. We kind of diminish the scope of the integration test, which also is or gets obvious from the fact that we don't actually need the inventory instances around, right? We can actually bootstrap, we can start the checkout only, and we with the Spring Modulith, if you have the checkout implemented in a dedicated application module, then it would actually do that. It would only bootstrap that vertical slice of your application without even considering the inventory or what have you. It wouldn't need to be instantiated. It's similar to this is like, of course, like microarchitecture, architecture within an application. But if you implemented that arrangement as microservices system, right, you would also strive for the idea of being able to check out the test the checkout service independently and not necessarily have the inventory around. There might be other test cases that do that, exactly that, like have a like end-to-end integration testing. But we've seen a lot of teams that like move to microservices to be able to just test a vertical slice of the application independently, and that's what you can actually like do and get with in this particular case with Spring Modulith, right? Spring Framework, Spring Modulith, right? And that's what I said here. So like more for the reference later on if you look up the slides. Okay. So while this, you can look at this kind of arrangement from two different points of view. This is basically the registration view here, right? So the event listener expresses interest in the order completed event provided by the checkout. When at runtime, in fact, what happens is that the event is published to the Spring application event multicaster, and then these event listeners get invoked by framework code. So to summarize that step, we have changed our structural arrangement primarily, right? So we've basically moved from an orchestrating arrangement, like one component needs to know about all the others, to like the others kind of attached to the original, to the primary functionality. That means that's as a consequence, that changed our approach in testing, right? We're not testing for the orchestration anymore, but for the signal, for the outcomes, which allows us to kind of like focus the testing on a particular logical unit of the application. But we didn't change our consistency arrangement. That's kind of nice. It's probably a good point here to have this quick break to make sure you understand. I'm not suggesting to always do that step and always do that kind of shift from DI to event-based interaction. For one, it's not always possible. If you have a like, let's say, I don't know, foreign module Spring Bean that you need to invoke that will return a result, you could like try to fake that with events being published from the other side, but that doesn't really work, right? So it's kind of like an interesting approach if you all you need to do is a fire and forget scenario anyway. The second thing is that this event-based interaction already, if you're not used to that and you've like done 15 years of dependency injection, it might require a bit of time to get used to this model, right? Because you're kind of like decoupling things more, and then it's not immediately clear who is actually reacting to that event. So there's a bit of like, oh, you probably have to find all the code that references the event type and whatnot. So if it requires a team to get used to this thing. And it also means, and that's a bit of a risk to that approach, is that you're testing something like the checkout, and you kind of, that test is green, right? You publish the event, you expected it to be published, you're good, right? But at runtime, you now have the inventory and the rewards program and all that other stuff to actually play into this scenario, and you might just run into I don't know, the inventory throwing an exception and that breaking the functionality, the checkout that you've just like assumed you have tested properly. That's kind of a bit of a risk of this approach, right? So it has some benefits, but it also has some downsides to it. Has there been like any questions so far, Hanno?
I haven't seen any questions until now. A lot of people are friendly saying hi. I do want to ask you a question of my own, if that's okay.
Go ahead.
So in the second example you showed us, like the asynchronous way of passing events to these three submodules, right? Inventory, reward program, and notifications. I could imagine that your customer says it's very important that inventory is updated right away, right? Because I don't want. What if someone orders the last item, right, and the checkout is busy? What if someone tries to order the last item while it is being processed and paid for? Whereas the reward program and the notifications bit, it's quite okay to process that like 1 minute later or 5 minutes later.
Yeah.
So what would you answer the customer that has this kind of?
So like for one, we haven't actually touched or tipped our toes into asynchronicity yet. All of the stuff that I've shown you so far is still synchronous. So you would still get the rewards program and the inventory potentially be able to veto the entire process. But you're touching at a very good point, which is that not all of these secondary functionalities are kind of created equal. And it's perfectly fine for you to still invoke the inventory directly, but then switch to an event-based notification or of the rewards program, right? So that's kind of this, like no application I've seen is like using one or the other approach like distinctively, right? So it's definitely it's an architectural tool even to like what kind of guarantees do you need, right? Especially when it comes to asynchronous event handling, which we get into right now. So it totally makes sense to mix and match these approaches, really.
So just as you're answering that question, thank you very much for the answer, by the way. A question showed up, so I'll share it with you on the screen. So Marianne says, I haven't tried the Spring Modulith yet. Do you know how much adoption it has so far?
I can probably spend like a sentence or two on that, but let me push this to the end of the talk when we summarize it. Sure. But it's a very good one. It's a very good one.
Okay, well, we should visit the question at the end, Marianne. Thank you.
Yeah. All right. So coming back to the our state here, and now that we've changed our approach to that topic structurally, right? So we've switched from DI to the event-based interaction. That didn't change our like consistency arrangement, right? So we still have transactional spanning the invocations of all of these different parts of our application. So an issue with that might be, and it's kind of like try to come up with an example here, is that while our checkout, our inventory, and our rewards program interact with the database, our notification system might not necessarily do that. It might just want to try to send out an email, and by that, or for that, reach out to an SMTP server. So this immediately raises a couple of questions. Like for one is like the SMTP server probably is not really taking part in the transaction, right? So we might run into consistency issues with like the notifications being sent out or not, or the transaction being rollbacked. What happens to the successfully sent out email? Also, it's actually the first point I was trying to make is that also means that the database connection that we open up to back the transaction, like on our invocation of the primary functionality, would have to stay open until we've sent out that email, right? So where it actually it just might like significantly increase the length of the connection consumption, and by that immediately lead to higher pool saturation and what have you. And the question is there a way to actually approach these two problems? So coming back or switching that example that we've just seen, like just as you see here before, but flip to the notifications example, right? So if we followed my advice to, let's say, switch to an event listener for notifications as well, we immediately raised the question, like, what if this talking to the SMTP server takes long? And there's a second question is like, what if sending out that email succeeds, but then for some reason, I don't know, our database connection is gone, database is down, we cannot actually commit the transaction. And we sent out an email, but actually haven't marked the order as complete. So from an like logically, like this, in with regards to consistency, this basically looks like the following. So time is flowing from left to right. We invoke the method, we create that original business transaction, and that causes the consistency scope to span the checkout part of our system. And then by the virtue of invoking our event, we actually initiate the add event listener method, which is then reacted to by the inventory module, so that inventory becomes part of our consistency scope, basically. Right? That's kind of the starting, or the way that we start from. So the fundamental idea is to like, wouldn't it make sense to sever the interaction with other resources from the original transactional boundary, right? So it would be nice if there was a way for us to attach the notification to, or the triggering of the notification to the successful completion of the transaction, right? And by that, separate that. And there's actually a Spring Framework feature for that. It's nothing to do with Modulith in particular, but it's basically the transactional event listener. Note that I've changed the annotation on the right side of on the method on the right side to transactional event listener. It's one of the annotations that I think could have been better named, but for the lack of a better name, we just named it that way, because it doesn't mean that this method is an event listener that runs in a transaction itself, but that it's attached to the commit of the original transaction. So what's going to happen here is that while the events.publishEvent method, it publishes the event to all standard event listeners, it will keep basically an object instance around until the transaction that surrounds the complete method successfully commits, and post-commit, it will then invoke the notifications on method here in the transaction cleanup phase. So what that essentially means is that notifications on is guaranteed to have the original transaction to be or having been committed beforehand, right? So we only send out emails if the order has successfully been processed, right? So it basically, just coming back to this thing here, the event publication is kind of delayed to the commit, right? So all the standard event listeners are still invoked, but what we do is we invoke the transactional event listener post transaction commit, right? Which means that the transaction is even prolonged. So it's still in committed state, but the database connection will still stay around until we've actually successfully or exceptionally completed the transactional event listener. Which means that we've even increased our consistency scope and basically just push out the notification stuff to the right side here. With the inventory would probably still be part of the original event publication. So it's still kind of all encompassing here. So what can we do to prevent that? Or it's we've solved one problem, right? We solved the problem of having sent out the email while the order might still not be completed fully. But we now kind of treat these calls sequentially. And what can we do about that? And one thing is to actually run this transactional event listener asynchronously, right? This would cause this scheme here to change as follows, because the transactional event listener is invoked. It will be additionally decorated with some kind of handoff of the execution of the method to a separate thread. That's that cleanup call, or that call to the thing would immediately return, which means that we would kind of separate this execution from the original one, so that the original transaction can actually commit and end, like not right at the same time, but pretty immediately after that other functionality has been kicked off. So we create a new transaction, like a new kind of consistency scope outside of the original one, which helps us to keep the original one small, but then also creates a challenge. Like what happens if the transactional event listener then fails, right? So we complete the order state transition, but also we cannot talk to the SMTP server because it's gone. So it, I don't know, times out, throws an exception at some point, what have you. For that problem in particular, Spring Modulith ships with a solution that can also be that can be used kind of relatively independently of all the other features of Spring Modulith. So you don't necessarily need to opt in all to the structural suggestions we make for Spring applications, because it essentially works entirely based on transactional event listener declarations. So the idea is as follows. When we publish the original event within a transaction, the framework knows about all the transactional event listeners that are present in the application. So even before it commits the transaction, it creates additional database entries for each of the event listeners in the database with the original transaction. So we wouldn't only, in our case, basically change the database state for our order, but we would also add entries into the database that says order completed event for inventory, order completed event for rewards program, order completed event for notifications. On transaction commit, the standard transactional event listener invocation takes place by the framework. But the functionality of Spring Modulith will have decorated the event listener in a way that if it succeeds, I mean, we have the database entries, but if it succeeds, that would scratch that entry from the database. So it would basically put a check on, oh, inventory update has succeeded, right? Scratch that entry from the database. Rewards program failed. We keep that entry around. Notifications failed. We keep that entry around. Some other secondary functionality succeeded, we scratch that entry. So the result of the overall operation or processing would be our order having completed the state transition, right? It's still incompleted, but we know that we still have to update the rewards program and send out the notification email. And then we provide some API that you can use to, with all the failed events that consider like orders, for example, like retry them, right? So for example, if the SMTP server, your operations team has fixed the instance, it's available again, you can basically resubmit all the email send out notifications. That's kind of the idea, right? While the notifications, I've used the notifications example for that approach because it was using a separate resource anyway, and we have all these like resource related challenges that we have to solve here. But we could also get to the idea that, well, maybe we could, I've used the inventory here, but the rewards program would, or any kind of other secondary functionality would be subject to that way of processing as well. But at this point, as we're dealing with the database, we actually want to make that event listener code transactional in turn. And at some point, this gets a bit ridiculous because then you have an add transactional event listener annotation here for something that's basically expressing like, oh, here's some secondary functionality invocation that we want to like just attach to the original execution or process, but just execute asynchronously. That's why Spring Modulith basically just provides it's basically just a composed annotation that says application module listener, because it's kind of the interaction model that we promote as a default interaction model when it comes to module cross-module interaction. The reason for that being, and it kind of ties into the question that Hanno brought up earlier, is while it's still correct that you don't necessarily have to switch to that model. And for some, in this, I mean, I'm using it for the inventory here, but you're right. If you want the inventory to be part of the strong consistency scope, then you wouldn't use that thing here. But as Spring Modulith kind of focuses on like having or letting an application module being the primary abstraction or the primary encapsulation mechanism for, or structuring mechanism for an application, we kind of think that the greatest degree of decoupling is achieved by like triggering all the other functionality through that, if that functionality is even triggerable that way, right? Meaning it doesn't require an immediate result or what have you, right? But again, it kind of caters into the idea that you as an architect have the just different tools lying around, essentially, with like you can invoke the methods directly. You can add event listener them to just like structurally decompose the system better, or even from a consistency and execution point of view, also tweak them or make them decouple them more, right? When it comes to testing, the asynchronicity, of course, adds a level of complexity here. And we kind of try to conquer that with the introduction of the scenario API. So this is something that's coming from Spring Modulith, again, a JUnit extension that allows you to kind of like, as I said, we're putting these application modules, well, trying to treat them as first-class citizens and then provide testing capabilities for these application modules, which means that we think of them as like opaque boxes, or not opaque boxes, but black boxes. It's something you cannot look into. So, but you can stimulate the thing, right? Either by triggering a method on its API, like with the checkout.complete invocation here, or there's an alternative overload of stimulate where you can just publish an event, right? And then see the module react to that. And then there is some kind of, as you see here, some API or DSL to set up the expectations. And that will automatically deal with all the asynchronicity right here, right? So because if you have a module that publishes an event, another module reacting to that asynchronously, but confirming its completion with issuing another event, then there's like all kinds of like, you have to wait for all the things to happen. And what do you do? Like thread sleep for an anticipated number of milliseconds. We use a library called awaitility under the covers here that basically periodically tries to wait for that event thing to appear here. Another flavor would be to wait for some state change to appear at some point, and it's, I think, using 500 milliseconds periods, and I think the default timeout is at 10 seconds or what have you. And of course, the toArrive method has additional overloads to then I don't know, verify things on the event that you've kind of expected to happen, or the outcome of the original method invocation. Zooming out a bit again here, the point here being that is we kind of suggest that you kind of like focus or align your testing efforts and your consistency efforts with the application modules, and we provide you the necessary means to easily write tests for that, right? So to summarize the entirety, all right. So I'm something that's very important to me personally is that whatever kind of decomposition approach you follow, it should be functional first, and then there's nothing wrong with hexagonal architecture, with onion architecture. It should be a secondary decomposition strategy, right? Have your modules first, your functional units, and then you might end up with one project or one module that has a lot of, let's say, external integrations, and you choose hexagonal architecture for that, because then you can neatly add your adapters for, I don't know, for messaging, for SOAP, for what have you. But this is part of the functional module, and it's an implementation detail. Another module might be just as simple that you, I don't know, take your Spring MVC controller and then use JDBC template to just query some data from the database. So you're not even like introducing some boilerplate service layer, what have you. So choose the tool that as simple as possible. There is this nice quote I ran into like a while ago from John Gall that says, every complex system working complex system originates from a simple working system in the first place. You cannot actually start with a complex system in the first place. So keep it simple and try to set yourself up to be able to find the most simple solution to whatever you have here, and like as a secondary concern behind functional decompositions. Yeah, the functional boundaries are decent boundaries to align other like work activities, programming activities to it, like the consistency scope, the testing. In my Spring Modulith talk, I also go into the topic of documentation, right? So these units, these functional units, make a perfect boundary for describing what it does, what kind of events it publishes, what services it exposes, and what have you. But this talk, it was like focused on consistency and testing. Yeah, and that's basically reiterating on the fact that I don't expect anyone to like globally use Add Application Module Listener. A good example is a project that I'm doing with the local university here. It's a Spring Modulith application, but it's students working on it, mostly third semester students with hardly any Java experience, in which we use the structural decomposition mechanisms of Spring Modulith, but we totally avoid the Add Application Module Listener thing, because dealing with asynchronicity would just way beyond the way the level of skill that they bring to the table. We use a bit of event listeners, but we keep the consistency thing still very simple, and it's kind of just a good balanced middle ground of approaches. And of course, I think you've got that from the talk, that the Spring Modulith project is kind of like helping you with all of these challenges and being a good starting point. Which doesn't mean that you cannot apply these ideas to, I don't know, other frameworks, other languages even. I'm just not like actively working in them, but I think sending out events and reacting to that is equally well supported, or similarly well, in the Jakarta world. The final one, and I was kind of, when I watched Hanno's talk yesterday, he had this slide that it's actually not meant to be a slide, right? Because it's so dense on information, but it's still a nice way to like categorize things and what have you. This is actually taken as a page from the book, even, and it's actually trying to compare these different approaches in from different points of view. And the important bit here that you should probably take away with is that the from moving from the classical, like Spring Bean DI-based approach to the event listener approach, changes the way that the tests rows are kind of set up. Whereas the event listener to application module listener step then additionally changes the consistency approach, right? So it stays the same for the first two columns, but then changes with the third. So it's kind of like which parts of your architectural concerns do the individual approaches actually reach out into. But you'll get access to the slides, probably something to study later. There's a bit of sample code I have in the general Spring Modulith intro talk. You can find that here. And with that, I'm open for questions, actually.
Well, that was a very nice time we spent with you here, Ollie. Thank you so much.
You're most welcome.
Very intrigued by your talk, and kudos for including slides that are way too dense. But I always say just take a picture with the phone, right?
I literally had to laugh out loud when I saw you presenting that way.
Because you were like, I'm planning to do that tomorrow.
Because I always apologize for the slide, but at the same time, I think it's valuable. It's might not be like the thing I want to spend too much time on talking about it, but for reference later on, I guess it's a good one.
And people can always, pause the recording of the live stream later. So
sure.
Okay, so the first thing I want to share with you is just a compliment, right, by Vincent. Thanks for the presentation. I'll dive into Spring Modulith, and congrats on the slides. And I'll second that. I think your slides looked very slick, very clear, very easy to follow.
Thank you.
So thank you for that. And we've actually got a few questions, and I've waited until the end because most of them were quite generic and not at all regarding the topic that you were talking about. So let's start with one from Marian that we promised.
That we've delayed. The adoption of Spring Modulith. So This is a good question. I probably have to start by saying that, like, I've been working on Modulith since 2017 as a side project to start with. We turned it into an official project and released as 1.0, I think, in 2023. So it's like officially, it's like one of the youngest. If you take Spring AI out of the picture, it's one of the youngest projects in the ecosystem. That said, even the predecessor, basically the implementation I had before it was an official project, had been in production with some of our customers, because they were kind of like always solving an issue here. And we have a couple of them. One I think that I can officially talk about is like Air France KLM. They've rewritten an internal application and with which they monitor like the political developments and how those influence the flight routes of their planes with Spring Modulith. There's a couple of other things that I'm like tangentially involved with. So we see it being picked up. Like, I'm just about in an hour, I'm going to have a call with another potential prospect customer of us, but about that topic. That said, it's of course still a bit, in terms of download numbers, it's a bit away from the Spring Datas of this world and the Spring Boots and what have you. But to be blunt, and you can probably take this with a grain of salt because I'm the lead anyway, but I don't think there is a reason for a new Spring Boot application not to use Spring Modulith in particular. Primarily because it just like gives you that structural guidance and arc unit rules that help you basically verifying that your code still adheres to the structural arrangement that you built in the first place. So, and it's not, at least the default level of using it is not even touching your production code actually, right? So it's kind of like just a nice helper for you at build and compile time, and then everything else is just a standard Spring Boot application, which makes it also so appealing for new developments. But yeah, I hope that helps. We're basically on the same release train as Boot, so we've just shipped. I have to announce the 1.4 M1 release that I shipped yesterday. But yeah, we're kind of on track, and we're rolling. It's interesting times.
Yeah, very cool. Okay, thank you for that. So the next question is by Daniel, and he says, what is the primary use case to use event-based communication instead of DI for dependencies to communicate within a Spring project? What is the key differentiator? And he continued to elaborate on his question. He said, based on the use case you are presenting, I would say you would use DI for the dependencies that are crucial for the transaction to be successful, and events for those that aren't crucial.
Yeah. I guess there is like, if you basically solidly base your interaction on DI, the projects that I've seen that outgrown and like that are not like toy projects, they immediately have to deal with the fact like, oh, this thing needs access to 3 or 4 other things, and that kind of puts some structural. You immediately put together some very strict structure in terms of evolvability of the overall system, and that is primarily reflected in tests. That's why I also have those so prominently in the talk here, because they are kind of re-implementing the structure that you put into your production code, right? Because you verify that the inventory has been updated. So you kind of ossify your architecture right from the start with that. And the more flexibility you can actually retain or regain from moving to that approach, or even starting with it in the first place, just plain event-based interaction, that basically frees the structure a bit. What we've also seen, and that's kind of even more backed by the application module listener approach, is that what that does is it kind of moves your consistency characteristics in your monolithic applications towards the consistency characteristics that you will have to deal with once you split up the system into a distributed system, because then there is no global transaction surrounding everything anymore. So the more you can actually get to that arrangement, the easier it is to also split out one of the modules into a separate system, because you literally just take the package, put that into a new Spring Boot application, and then replace the internal eventing with some Kafka or what have you. That's like it's all supported by Spring Modulith, easily done. It just wasn't part of the talk here. But it's kind of the fact that in a monolithic system, you have these options that you can select from, and then gradually move to those to that arrangement. So you can, if you can foresee that, oh, here's a part of the system that it's likely to be extracted at one point, then you can stick with add application module listener for that only and keep everything else DI, right? It requires a certain level of like a glass ball, but you get what I'm saying, right? You can be prepared to later split up the system without actually you putting in too much effort and like putting in a Kafka in the first place, and I don't know, let these modules immediately talk to each other via Kafka or what have you. So it's a bit of a prepare for something, but you might just be end up being fine with just the modulithic modular, like the real modular consistency decoupled way, and be good with that and never distribute in the first place. But yeah, so that's the BS and use case. I would say you use the I for dependency. Yeah, so it's definitely, I guess that's probably a good checklist, like when to use which approach. But Modulith is very opinionated on like the module being the scope for the things. But there's nothing wrong with you even thinking, oh, I don't have no pain with dependency injected. Connected dependency injection connected components, and then you're fine. I'm not trying to find a problem here, but when you have the problem, like what are the potential solutions, and then it's good. So,
it looks like your answer was helpful, because Daniel says thanks, Oliver. So
you're most welcome. I mean, if in doubt, right? Even if we don't get to answer any questions here, drop me an email or find me at the socials. That's good.
Yeah, that's always a good idea. Thank you for offering that. So as far as I can see, we're getting to the final question now.
Good.
By my good friend Wim de Blauwe. Very nice to see you also here in the chat, Wim. Are there plans to move the event handling parts of Modulith into Spring Framework proper?
Hi, Wim, by the way. Good to see from you or read from you. It's of course on our radar, right? People are asking because, as I mentioned, the event publication registry is not necessarily part, or it doesn't really, it's not tied to anything else that's in Modulith. At the same time, there are a couple of things that, for example, for the support I've shown was like using relational databases. So there's the JDBC implementation, JPA implementation, what have you. But there's also implementations for data stores that are supported by Spring Data, just such as MongoDB and Neo4j. And by Modulith basically being placed very downstream of all the other Spring projects, we can easily consume those. If those implementations were like living in Spring Framework, those MongoDB Neo4j specific ones would need to be in Spring Data then, and so it would complicate the dependency arrangement a bit more. And we have a history of like things evolving outside of Spring Framework and then moving to it at some point. And I'm not ruling out that to happen at some point, but it's not on the radar for, definitely not for 7.0. We'll see what happens later on, because it also like there's quite a bit of like sophistication in what it does, and I don't know, we're not sure whether like all the additional questions that come up with that functionality, like how about retries, resubmissions, concurrency of those resubmissions, what have you, whether we want to answer those on the Spring Framework level, because there's a bit of opinion going into that. And also with Modulith, I have a higher cycle of I can release every 6 months. With Framework, it's every year. So we're kind of using that freedom to iterate a bit on what we have here, but it's definitely something that we have on our radar and might end up appearing or happening at some point.
Okay. Well, thanks for all the good questions, everyone. And of course, thank you, Ollie.
You're welcome. I realize it's gotten dark here. I'm sitting in the dark. Yeah. All right. Thank you very much.
Yeah.
enjoy the rest of the conference.
Yes, thank you everyone for tuning in. So another talk has started, a few minutes ago, so you could switch that. Hope to see you again at J Champions Conf, and if not, see you somewhere around the globe at one of our Java events. Hope to talk to you soon. Thanks for all the attention. And have a great day, everyone.
Take care.
Take care.